The most important thing you're going to learn in all of physics class, okay? If you would like to make physics as hard as possible, you will at some point stop doing all the things I'm about to put on this board. That is how you make physics extremely difficult. That's fine if you want to go that way with it. I highly, highly don't recommend. So, starting, we are about to do equations and word problems for the first time. That's largely what physics class is. The other half of it is looking at graphs and understanding what they're telling us, using that information, applying concepts, and answering a question. But a large chunk of it is being given information about a situation, using an equation to solve it. Either with numbers, like we will do today, or we've seen those comparison questions where we do it without numbers. We'll see more of those later. So for right now, we have 3 equations. These are the only ones we can use. V is equal to V naught plus AT. That's our first kinematic equation. X is equal to X naught plus V naught T plus 1/2 AT squared. That's our second. Third and final, V squared is equal to V naught squared plus 2AX minus XO. That's exactly how they're written word for word on the equation sheet. I'm going to write in pink underneath 2 of them a tiny change I make that I use sometimes, okay? Sometimes I write this first or second one as delta X is equal to V naught T plus 1/2 AT squared. All I did was subtract X naught to this side because X minus X naught, final position minus initial position is displacement. So a question might give me displacement instead of initial and final position. It might say the car drove 200 meters. I don't know where it started. I don't know where it ended. So you might think to yourself, I don't know final or initial position. But you do know displacement, right? I can always get that. Same thing for this one in pink. I can rewrite it, and I sometimes use 2A delta X. So again, that's just displacement. X minus X naught is displacement. Yes, I.
Could you modify the third equation to be change in v velocity squared?
Change in, yeah, but it's not this equation.
Oh.
Right? That's what you're thinking of. I can modify that to be change in velocity over time, which is acceleration, which is where it came from, right? This one's a little more complicated than that. All right. So here is the most important part of physics you're ever going to learn, okay? When I need to solve a physics problem, I'm going to follow the same method every single time. And I'm going to focus on doing one thing, which is the guess method. I might have mentioned this last class, I'm not sure, but that means I write out my givens, my unknowns, I pick an equation, and I solve. Really, that's substitute and solve, and I'll do both. Here's the next most important thing, okay? Next most important thing. This is extremely important. I'm going to do this method, but this method only works and is only foolproof and only makes AP Physics easy if you do the next part. Show all of your full work. We don't skip a step. You show all of your work, all of it, all of the work, not a portion of it. You show all of your full work, all of your work, okay? All of it, not a little bit, the whole stinking thing, okay? So I'm going to demonstrate that, and I'm going to show you what I mean by showing all the work, because I'm guessing right now I'm about to show more work than you ever thought was possible, okay? Let's do one. We're going to use this method, guess, to answer all of our questions so that nothing has to be hard. So, for example, a car sped up to 30 meters per second over 300 meters with an acceleration of 2 meters per second squared. What was its initial velocity? That's the question. So a car sped up and got going all the way to 30 meters per second. It's going so fast now. Over the course of 300 meters. With an acceleration of 2 meters per second. What is its initial velocity? All right, here we go. Showing all of our work. First, I write out what I know. Okay? So, Noah, what's one thing that you know? Based on this question. Anything. Yes, Noah. It's okay. Noah, what's one thing that you know? Acceleration. A is equal to 2 meters per second squared. Notice I didn't just write down that number off by itself, doing nothing. Don't even know what that means. No, I wrote A is equal to that. Okay. I also wrote the units. You're going to be like, no, I'm not writing the units. That's so much time. It will check yourself for errors, because what does the units for acceleration always have to be? Meters per second squared. So if you accidentally read a question and write something down, you're like, oh, it's 10 meters per second. That's a great way to catch yourself. Wait a second. Meters per second isn't the right unit. So write your units. All right. What is something else that I know? Ayush.
If the car traveled for 300.
Okay, so what variable is that? What variable do you want to use for that? Can't just have a number. We got to know what it is. What variable do you want to use for the 300 meters? Change in x, absolutely. Displacement is 300 meters. Very nice, very nice. All right. One more thing that I know. Who wants to tell me what it is? Yes, Farner.
Final velocity 30.
Final velocity is 30 meters per second. All right. What is it that I'm looking for? Initial velocity. All right, cool. Just going to write this. V is equal to question mark. Is that good? Should I leave it like that? Does that make sense? No, absolutely not. Show all of the work. That includes writing down the correct variable and the actual correct one. Don't just put V. Don't be lazy. Because then the next thing that's going to happen is you're going to look at your equation and be like, wait, which, I have two velocities, two final velocities? That doesn't make sense. How could I use I can't have two final velocities. Then you're going to get stuck in your head and lost and confused and be done. No, this one is initial. Write it down. The number one thing a high school student is, especially when they're really smart and know how to do algebra and math, is lazy. You just don't write it down. So quickly, that will just turn into a V and not written it down perfectly. Write it down. All right, then the next question, the next thing we have to do is pick an equation. So here's the best news about picking an equation. If you pick wrong, you're going to figure it out. If you pick the wrong equation, let's say in this case I picked the first one. And I start plugging things in. I put in 30 is equal to V naught, I'm looking for it, plus A, oh, I don't have a T. You're going to figure it out. So this is not a high stakes part of the question. If you pick the wrong equation, you'll know, and then go pick a different one. But here's how I pick. I look at my list, and I figure out which equation has those things and only those things. So here, I've got final velocity. I'm looking for initial. Oh no, I don't have T. That one's out. All right, next one. I have delta X. I'm looking for initial velocity. Oh no, I don't have time. All right, that one's out. Next. Final velocity. I'm looking for initial, I have acceleration, and I have delta X. Congratulations, you figured out the equation. Again, low stakes. If you mess it up, you're gonna find out. You're gonna realize, I don't have that thing I need. Let me pick a different equation. Still showing all your work. If you're ahead of me and you've moved on and you're solving a question, did you write out which equation you used? Always write out which equation you used. Because the first thing you're going to do is just be like, okay, that's the equation. Start typing things in your calculator. You don't remember which equation you were using. Somebody talked to you. You got distracted. Oh, do I add something? Where's the T in this? Oh, no, I don't remember. Write the equation. Then continue showing your work. 30 squared is equal to V naught squared plus 2 times 300. Keep showing your work. I know a lot of you in your head are like, no, I can just do that in a calculator. I'm just going to stick that in Desmos. What are you talking about, Ms. Limer? I'm not going to do that. Stop it. Bad. Show the work, because this is where you mess up. This is where the problem happens. You're like, I've got this. It's all easy. And then you mess up right here because you're not paying attention. And you can't figure out where you messed up when I give you the test back and you got the wrong answer because you don't know. Keep showing work. Ooh, of course, this is the one I videotape. And it's not possible. Why is it not possible? That's a 300, sorry. Yeah, I can't do the square root of that. Okay, I'm going to change one number. Let's see. What number do I want to change? I'm going to change. I can't get to 30 seconds. That's so sad. It has to have an initial. Okay, so I need to make this higher. I'm going to make that 60. Problem solved. 60. That makes this 3,600. Look at that. Haha, now I've solved the problem. I make these up as I go. Sometimes they work out, sometimes they don't. All right, 3,600 minus 1,200 is 2,400. Now I can take my square root. V naught is equal to 49. We'll call it 49. Is that 100% accurate? What do we think? Probably not. What do I think I need to put out in front? No, I'm not worried about 100%. That's not what I mean. This is wrong. It's flat out wrong. Should be negative. Should be negative. That's the thing there. I know it should be negative because I just did this problem and I thought about it and I was like, well, if I couldn't speed up to 30 and 300 meters, I'm not speeding up by 11 meters per second and 30 meters. So I must have started at negative 49 and then gone from there. Most of the time this isn't an issue, but you can always go test it, right? Pick another equation, test it. Should it be positive or negative? In this case, that seems fine. That's how I solve a problem. Let's do one more. Erase all this. I would assume that has to be negative. Let's see. Stop. How long does it take to go from 0 to 60 meters per second at an acceleration of 1.25 meters per second squared? How long is it going to take me to go from 0 to 60 with an acceleration of 1.25? Could you do this one entirely in your head? Probably. But we're not going to, because we're going to show all of our work every time. We're going to follow the same method every time, so that way it never has to get hard. Like, why make it hard? Why try and do it in your head when that's going to be harder than just figuring it out? Yeah. Yeah.
Do they take out points in like the AP exam when you don't show work?
No, absolutely not.
Yeah.
Let me qualify that statement. Let me qualify it. And multiple choice, obviously not. For the FRQ, there are questions that will specifically say, show the multi-step derivation to get from here to here. It won't include numbers. It'll just be an equation that you're manipulating. But it will say, show the multi-step